Okay, welcome everyone to Cloud Data Driven Online User Group Meeting. As you guys already know, our agenda is a crash course on Synapse Analytics for Power BI developers. For your information, these sessions will be recorded. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years. I'm currently located in New Jersey, however, originally from Haiti, and I'm your host for today. The rules are you guys are free to comment, but there must be no offensive comments. I have your camera turned off. However, I would highly suggest you to keep your microphone off, and you are free to raise your hand if you have any questions. Please let us connect together. Follow us at Cloud Data Driven User Group, and also visit our data community, which is datasaturdays.com and SQLsaturdays.com. Also, we are launching for the first time feature data driven event. I would highly suggest you guys to go and save your spot. Today's presentations, we have Nikola, Ilic. Am I saying it right, Nikola?
It's Ilic, but never mind. It's hard to pronounce. Don't worry.
That's fine. Thank you. He is an MVP and also Power BI and SQL Server addict. He's a Microsoft certified trainer, and also he has some great content on Prio site. I would highly suggest you guys to go and visit his video course up there. And then he's a blogger, he's a speaker. He's gonna introduce himself and tell you more. So for future presentations, we have Kevin Clark and also Mark. Yes, I would highly suggest you guys to go and reserve your spot. And then if you guys have any questions, if you guys want to present a session, feel free to email me at jean.joseph@bigdata.org. The floor is all yours, Nikola. It is an honor to have you here. You can start sharing your screen and start with your presentation. Thank you
Thanks,
all.
John. Thanks, John. So I'll start sharing my screen. And so hi, everybody. Good afternoon or good evening from my side. It's evening here in Austria at my place in Salzburg. So I'm extremely happy to be with all of you here. First of all, thanks, John, for giving me a chance to present for Cloud Data Driven User Group. Today, I want to talk about Azure Synapse Analytics, or to be more specific, about serverless SQL pool within Synapse Analytics from a perspective of Power BI developer. We will try to cover some interesting scenarios and understand how these two products work in synergy. So make yourself comfortable, grab a coffee or some other refreshment, and we are ready to kick off. So before we start, let me just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last 5 years I live in Salzburg in Austria, where I work as a business intelligence developer at company ITSP Services. Living in Salzburg was the reason why I've chosen my nickname Data Mozart. You probably all know that Salzburg is worldly famous as the birthplace of Wolfgang Amadeus Mozart. So I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. You can find me on web, as John mentioned, I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter, so feel free to connect if you like. Other than that, I have multiple year experience working with different data products, predominantly Microsoft Data Platform. I'm also Microsoft Data Platform MVP, Microsoft Certified Trainer. Privately, father of 2 kids, and through football and bars of fun, as you can conclude looking at the photo on your screens. Okay, let me briefly walk you through the contents of our today's presentation. We will start with quick comparison between traditional and modern data warehousing concepts in order to put our discussion in the proper context. Then I will introduce you with Azure Synapse Analytics and core components of this platform, which will enable you to better understand the next unit, which is a serverless SQL pool. We will talk about what is a serverless SQL pool, why should you consider it for your analytical workloads, and finally, in which scenarios would it make sense to go this path. We will then examine different techniques of using T-SQL to retrieve the data from semi-structured and non-structured sources such as CSV or Parquet files, or even NoSQL databases like Cosmos DB, for example. Straight after that, I will cover the best practices for using Synapse Serverless SQL pool and how to get maximum from this engine. Last but not least, as I'm sure that most of you folks are most interested to hear how much this costs, we will talk about pricing, what counts for the billing, how to manage your costs, and finally, how to save money in your wallets. There will be, of course, a few demos, so you can get you can get a better feeling of different features within Synapse Serverless SQL pool from perspective of Power BI developer. As I said, I know that this session is targeting Power BI professionals, but to be able to follow along, I will assume that you have some knowledge of Transact SQL, as I will often refer to terms and concepts related to traditional SQL Server and its SQL dialects, so T-SQL. So if you're completely new to SQL, maybe you will find it challenging to absorb everything that follows. Nevertheless, please don't leave the session because of that. Just feel free to ask questions if needed. Okay, so here we are. Once upon a time in a far, far away land. Just kidding, my story doesn't start like that. But my story starts with a quick look back to some concepts that were and still are omnipresent in the world of data. There are multiple ongoing discussions these days, maybe you're seeing on social networks, etc., about the relevance of traditional data warehousing concepts in today's state of play. I will not go, of course, deep into these discussions, just shortly express my belief that traditional data warehouse is far from being dead. It's more in kind of evolution phase, adapting to new challenges typical for large data volumes or different flavors of data sources, let's call it that way. Okay, so in a typical traditional data warehousing scenario, as you can see in this illustration, you would go and collect your data from multiple different sources, perform some transformations, data cleansing, etc., before putting consolidated data into a relational data warehouse. This was and still is the focal point of your reporting solutions, a single source of truth for your data, and then you can build various reports from there using a whole range of tools. If you're old enough like me, for example, Crystal reports or SQL Server reporting services, most recently, of course, Power BI, if we are talking about Microsoft solutions. You could also build an additional semantic layer using SQL Server Analysis Services or Azure Analysis Services to create cubes, both multidimensional and tabular cubes, and then target those cubes with reporting tools that I previously mentioned. And don't forget good old Excel too as a reporting tool. And if you think for a moment of traditional data warehouse, as its name suggests, like of a warehouse, you're close to truth. It is like a large store, and modern data warehouse is like an extra big distribution center. In this traditional large store, products are already unpacked, prepared, they're ready for use. So it's like someone extracted them from the boxes, transformed their original package, and loaded the shelves in the store. I think you get the analogy with ETL concept in traditional data warehousing, and they're ready for consuming right away. On the other hand, in the big distribution center, well, you see how the items are being stored there. But if I need to take a box of, let's say, Coca-Cola, I can also pull it directly from here without needing to go necessarily to my local shop to buy it and take it from the shelf. As you can see in this illustration, modern data warehouse accepts data from the whole range of different sources, structured, semi-structured, non-structured. This can be graph-like data from social networks, data streams from different devices, data coming from JSON documents, CSV files. So literally anything you can imagine what is capable of storing some kind of data. And now this big distribution center can keep the data in its original form without need to apply some additional steps in order to prepare this data for further analysis. So whole range of different data professionals can benefit of having a solution like this. Data analysts can use Power BI or similar reporting tools to create reports over this data, while data scientists or machine learning engineers can create and train their models right away. The key concept here in this modern data warehousing is that unifying experience that modern data warehouse provides. And that being said, there are multiple benefits that modern data warehouse provides. From technology perspective, modern data warehouse brings the following advantages. The first one, it is always, or let's say almost always available. Then it scales to extremely large amounts of data. It's also flexible because you can quickly get insights from literally any data source. That also means that less time is needed for data movement and data preparation. And finally, it provides reduced overall ownership costs. Do you recognize the object you see on your screen? Yes, it's famous Swiss knife. You can use it to cut the paper. You can open a bottle of wine or beer, or even cut some smaller items, and all of that using one single tool. So if you're asking yourself, what on earth does this knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data workload needs. For example, do you need to import data from multiple different sources? Synapse can do that. Do you need to transform data before serving it? Synapse can do that too. Do you need to store the data? Synapse can do it for you. Do you need to query non-relational data or even files directly? Synapse can do that. And watch out now. Do you need to query non-relational data or even files directly using plain old T-SQL? Synapse can do that. What? Yes, I hear you say it again, Nikola. Yes, you can write T-SQL to query data directly from CSV, JSON, or Parquet files, but more on that in a few minutes. Do you need to build machine learning models? Synapse can manage this for you. Finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. As you may conclude after all this story, Synapse is literally a one-stop service for all your data tasks. Or if someone asks you to define Azure Synapse in 3 words, you can freely tell that it's an end-to-end analytics solution. Fine, so here is the quick, let's call it 10,000 high feet overview of different components that make Synapse Analytics integrated analytics solution. For SQL professionals, there are 2 pools in Synapse. A dedicated pool, which is the official successor of former Azure SQL Data Warehouse. And then there is a serverless SQL pool, which will be the highlight of our today's talk. In this illustration, its name is a little bit outdated. In preview, it was called SQL on-demand pools, but don't be confused. That's SQL serverless SQL pool in Azure Synapse. Then folks familiar with Python, Scala, or Spark SQL can leverage usage of Apache Spark pool for processing large volumes of data. When it comes to storage, there are also a bunch of possible options to choose from, starting with traditional relational way of storing data in SQL Data Warehouse, then also Spark tables, Azure Data Lake Storage Gen 2 Data Lake, all the way to non-relational document style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. Finally, you can quickly visualize your data using, for example, Power BI. And watch out, here's the key takeaway from this story. You have all these tools under one roof, either natively, either as linked services. And you can build, manage, and deploy your end-to-end data solutions from within a web-based user interface called Synopstudio. So everything is performed there. We will take a closer look to this Synopstudio later in the session, as we need to now lay some more theoretical background. As you may notice on previous illustrations, Synapse Analytics offers 3 different analytics pools for performing different computations over your data. 2 of them are SQL based, which means that you can use familiar T-SQL syntax for querying your data. Also, 2 of them are provisioned, dedicated SQL pool and Apache Spark pool, which means that you need to set some kind of infrastructure in advance. And more important, that means that you will be charged not only for computing power, but also for the storage you are using. Now, when it comes to integration with Power BI, as dedicated SQL pool works more or less the same as traditional SQL database, and Spark pool is obviously out of the scope of this session, I would like to explain in more depth serverless SQL pool part of Azure Synapse architecture and how it works in synergy with Power BI. Again, before we dive deeper into a detailed overview, let's take a look from our aeroplane on its architecture. The core component of serverless SQL pool is distributed query processing engine called Polaris. Polaris Engine runs on the control node. Let me zoom it a little bit here. So Polaris Engine runs on the control node, and this node represents the brain of the whole architecture. Okay. Control node then splits the query into smaller chunks and forwards them down to compute nodes for execution. So instead of a query, we have something that is called task, and task is nothing else but a unit of distributed query execution. Last but not least, keep in mind that unlike in dedicated SQL pool where you are in charge for defining computing power and how many compute nodes you need to use, serverless SQL pool scales automatically to support your data workload. Okay, I promised in the beginning when I was introducing the agenda that we will try to answer to 3 key W's regarding serverless SQL pool. What, why, and when. So let's start with what. And I will try to keep this as short as possible, I promise. Serverless SQL pool is essentially, as I said, the distributed data processing system, or maybe it's better to say a query service that enables you to query data directly from the data lake using well-known T-SQL syntax. There is no any cost for the resources, storage, and so on. You will be charged only for the amount of data processed by running your queries. We will examine later what counts in the amount of data processed and how you can control it. At this moment, just keep in mind that serverless SQL pool is a typical pay-per-query model. Okay. In fact, you can think of serverless SQL as advanced polybase or cloud polybase, let's call it that way. Underlying technologies are not the same, but I would say use case scenarios are pretty much the same. In polybase, you don't have open row set function to perform ad hoc analysis, as everything is handled through external tables. But essentially, you can think of serverless SQL as polybase on steroids, as I like to call it. Now, as we hopefully answered what is serverless SQL pool, let's try to examine why you would consider using it. First and most important, you don't need to set up any kind of infrastructure or clusters to make this thing running. Once you create your Azure Synapse workspace, serverless SQL pool will be created by default. That means you can start querying your Azure Data Lake storage as soon as you create your workspace. And that significantly reduces time to analysis. As already mentioned, when you provision dedicated SQL pool or Apache Spark pool, you will pay not only for computing power required to satisfy your data workloads, but also for the data storage. Here with serverless SQL pool, you pay 0 for the data storage. Finally, learning a new programming language just for querying data from the data lake can be daunting for many professionals, especially those coming from the SQL world. Therefore, one big benefit of serverless SQL pool is the possibility to use well-known T-SQL syntax to retrieve data directly from let's say CSV or Parquet file, or even from the documents stored in Cosmos DB. In full honesty, serverless SQL pool, of course, is not a magic wand that will solve all your data requirements. So it's extremely important to understand in which scenarios you should consider using it. So let's answer to our final W. When would you use serverless SQL pool? First thing, I need to gain quick insight into the data which is stored in my data lake. I want to see maximum or minimum value within a column, or quickly identify some outliers. I will go and perform basic data exploration of the data stored in CSV, JSON, or Parquet file using serverless SQL, and then based on results, I can decide how to leverage this data for further analysis if needed. I want to build a kind of relational abstraction layer on top of disparate data stored between, let's say, CSV files or Cosmos DB and relational database. This way, I can build a kind of logical data warehouse without need to physically move or transform data in classic ETL way. So let me quickly show you what I'm talking about. I'm in SQL Server Management Studio, and I'm connected to my serverless SQL database, which is called, let me zoom it a little bit, Nikola Synapse, okay? And I have a bunch of views created here. So I will show you now how this looks like in the background. So here I have one CSV, one view which is based on a CSV file from Azure Data Lake. And let me show you the definition of this view. So I'm using open row set function, and I'm directly targeting CSV file which is stored in my Azure Data Lake storage. Okay, specifying some parameters here to retrieve the data, and this is normal T-SQL here. Okay, same here I have for example, for Parquet file. I have co-presenters here. Maybe you hear them or see them. So here I'm targeting Parquet file, which is public file stored. You can also do it same way as I did. So just specifying external data source and format of this file. And I'm using here two functions, file path, one function, file path, to partition the data which I'm targeting from this view. And in the end, I can go and combine all of these views into one single SQL statement. So here in this CSV Parquet union, I'm unioning data from CSV and Parquet files, and then I'm exposing it to end user like a normal T-SQL statement, so he doesn't have idea what is in the background. Essentially, here we have one view that combines data from CSV and Parquet files, and we have another view which comes from completely different Parquet file. And this from external point of view, this looks like a normal T-SQL statement. So like no one is aware that in the background we have multiple different stuff. Okay, that was a short example. Third reason to use serverless SQL pool is when you want to perform simple but at the same time scalable data transformation within the data lake itself, using the language you know, and that language is T-SQL, which a lot of people is familiar with. As you go and transform your data, it is quickly available for further digest by either reporting tools like Power BI or for loading into a relational data store like Azure SQL database or dedicated SQL pool, for example. How do you access serverless SQL pool? So serverless SQL endpoint is provided by default within every Azure Synapse workspace, and you can immediately start querying your data using either Synopstudio or usual suspects, as I like to call them, SQL Server Management Studio and Azure Data Studio. So let me show you quickly how you can connect to serverless SQL endpoint from Synopstudio. I'm in my Synapse workspace, and here you can see that I have this serverless SQL endpoint, which I need if if I want to connect to my Synapse workspace from external tools like SQL Server Management Studio or Azure Data Studio, I will go and copy this serverless SQL endpoint, and then I will just, here I'm already connected, but let me show you. I will choose Connect Database Engine, and then I will just paste my server name here and provide login credentials for connecting to Synapse Workspace. If you're connecting from Azure Synapse Studio, you will be automatically connected to your serverless SQL. I will click Open, and here, let's wait for a few seconds. And here I'm connected now to my Synapse workspace. I can expand these tabs on left to have more control over what's going on in Synapse Studio. I can click on Manage to see what kind of stuff is in there. So I can see my analytic pools. At the moment, I don't have dedicated SQL pool, only serverless SQL pool. I can also go to Data tab, and within Workspace tab, you can see all the databases you created, views within the database, and under linked services, you can go and check what is stored in your data lake storage. In my file system here, I can, at the moment, I have only this one data folder with some CSV files within. So I can go and write this SQL directly from there. How? If I right click, for example, on this CSV file and new SQL script, select top 100 rows, Synapse Studio will automatically generate SQL statement for me, and I can run it directly from Synapse Studio. Let's wait for a few seconds to see the results. And you can see here that we got our results back from CSV file. Okay. Now, I also want to connect to serverless SQL endpoint directly from Power BI and import the data into tabular model or perform direct query over the data stored in Azure Data Lake Storage. So let me show you how you can connect from Power BI to serverless SQL endpoint. Again, I will go and grab my serverless SQL endpoint path. Here I have a blank Power BI desktop file, and I will go to Get Data. Click on More. And here I will start typing Azure. I will choose Azure SQL Database to connect to Azure SQL Database. And I will paste the path to my Synapse serverless SQL endpoint. Okay. And once I'm prompted to select database I want to query, I can go and choose, for example, this view that I showed you previously, which is union of CSV and Parquet files. And I can open Power Query Editor normally like I'm importing data from a regular SQL database. Here, let me show you. So you can do all your Power Query transformations like you will do when you're using Power BI with a regular SQL database. So let's go and, for example, keep top 1000 rows. And once it's applied, I also want to check if this query false or not, so that the performance of data refresh, for example, is not being violated. So if we right click on this, you can see that this query faulted in the end. So you can use basically in the back, in a sense, you're using CSV and Parquet data, but you're exposing it to Power BI as a normal database objects, normal database tables, normal database views. Okay. So the key reason why we are all here today is to examine how to leverage usage of regular T-SQL syntax for querying data that is stored within your Azure Data Lake. So let's check which options are available when using T-SQL in combination with serverless SQL pool. If we take a look at database objects, here is the list of objects you can create within serverless SQL pool. The first and most important and one that you will use most frequently are views, as you saw in my example. You can also create multiple different schemas, same as stored procedures. When it comes to user-defined functions, you can use inline table value functions. Additionally, you can also create external tables, both regular external tables and citas. Finally, you can create statistics on your data in order to increase query performance. Things that are currently not supported are tables, so both permanent and temporary tables, as serverless SQL pool allows querying only external data which is stored in Azure Data Lake. The next feature that it's not supported, and this is really important to keep in mind, is caching of query result sets. That means whenever you execute the query, engine will go and scan exactly the same amount of data each time. So no matter if you are in SQL Server Management Studio, if you press F5 once or 15 times for one single query, each time this query will generate exactly the same costs. Keep that in mind. And you know, when we're talking about costs, when I'm reading SQL related blogs or watching videos, all folks, when they analyze execution plans, for example, talk about query costs. So you will often hear something like this query costs you 100 query bucks. This query will cost you 500 query bucks. Here, forget about the query bucks. So we are talking about real bucks, real money. So once again, you would want to think twice before hitting F5 button for no obvious reason. Okay, you probably already realized that serverless doesn't support any kind of data persistency in between data lake storage and query result set. Therefore, you can't create objects like materialized views, unlike in dedicated SQL pool where this kind of intermediate storage is possible. Finally, you can't rely on objects like indexes or table partitions. You can partition files using file path function, which will show you in this example with Parquet files, but that's a whole different story. So no partitioning in traditional SQL way. Okay, let me now walk you through what you can and can't do with these SQL statements. So whole set of features, or let's say almost whole set of features for select statement is supported in serverless SQL. You can also use explicit transactions on metadata objects and perform data export using CITAS statement. Apologies from my side, my bad. I mentioned CITAS on previous slide also. I didn't explain what is this. CITAS send from create external table as select. So it's kind of insert into in traditional SQL. Just you can imagine something like this. So you are exporting data to external table using select statement. Also, if you need to write cross database queries, that's also supported, and whole set of T-SQL built-in functions, except those three you see on your screen: Open XML, Open Data Source, and Open Query. Finally, data definition language statements are also available. So create, alter, etc. You can write all of this stuff in serverless SQL. What you can't do, you can't use insert, update, and delete statements. You can't perform merge within your queries. Within select statement itself, there are few limitations. Namely, you can't use for XML match and predict functions, and also query hints are not supported. And finally, you can't combine data coming from system views with distributed data. Fine, so far we discussed what is possible, in which scenarios you would consider using serverless SQL pool, but we still haven't explained how to get the best from this engine, or what are the best practices when you are working with serverless SQL pool. Nevertheless, if you're connecting to it with Power BI or some other tool, these are best practices in general. So let's start with a list of actions that you should perform in order to maximize potential of serverless SQL pool. Default storage account and serverless endpoint are by default in the same region. However, if you are accessing other storage accounts or Cosmos DB analytical storage, try whenever possible to place your serverless SQL endpoint and Azure storage accounts that you are targeting in the same geographical region. That will reduce the latency for the data's network transfer. If possible, convert your CSV and JSON files to Parquet format. Parquet format compresses the data, and this consequentially leads to smaller memory footprint of these files if you compare them to CSV. Additionally, Parquet is a columnar format and in many ways resembles to column store indexes in relational databases or the way that Vertipex stores data in Power BI. So because of that, serverless SQL columns in this structure are physically separated and data is being compressed. So serverless SQL engine can skip unnecessary columns when reading data from Parquet files, which is not the case with CSV. And this will, in the end, directly affect not just time and resources needed for processing the query, but will also reduce the cost of that query. Another very handy thing is called built-in schema. Built-in schema inference enables you to quickly query data in data lake without knowing underlying schemas and data types. And this is very handy because you can start, immediately query your data. But this handy feature, of course, comes with a cost. And the cost is that inferred data types are usually much larger than the actual data types. For example, Parquet files don't contain metadata about maximum character column length, and inferred data type is always varchar 8000. So even if you have a column, let's say for US state abbreviation, which is always 2 characters, it will be inferred data type will be varchar 8000. As I already mentioned, you can't partition the tables, but you can partition your files. And that being said, you can instruct serverless SQL to target only specific folders and files using file path and file name functions. This way, you will reduce not only the amount of data for scanning and processing, but also the real money costs. And one bonus tip when using file path and file name functions, always cast the results of these functions to proper data type. Another important remark, these two functions are currently not supported for external tables, except those which are automatically created in Apache Spark Pool. Next, take advantage of using CTAS create external table select whenever you can. This is one really of the most important features in serverless SQL. Using CTAS, you can store, if you have some frequently used queries, you can store them to a new Parquet file and then use this single external table instead of referencing same underlying tables multiple times. So it's not a materialized view as we used to know in regular databases, but it's still some kind of materialization. And this materialization occurs within the Parquet file that is stored in the data lake. On top of that, as the CTAS generates Parquet file, statistics will be automatically created when you query your table for the first time. So you will gain performance improvement for all subsequent queries that target this same external table. Every do, as you might expect, has its counterpart in don't. So here is the list of things you should try to avoid or at least reduce to a minimum. When you are running queries on serverless SQL pool, carefully plan other workloads that target your storage account. I already said serverless SQL has built-in capacity to resolve this kind of issues by sending requests to data lake at slower pace, but that will obviously affect the performance of your query. Again, avoid schema inference. I know that it sounds appealing to, quickly get up and running without wasting time and effort to handle inferred data types, but you should definitely spend some time resolving inferred data types to appropriate ones, as you will reap the benefits later, I assure you. Get rid of single large files. Instead, if you have extremely large files, split it into multiple smaller files and use file name and file path functions to reduce the amount of data that needs to be scanned and processed. With that in mind, try to keep your single CSV file size between 100 megabytes and 10 gigabytes. Fine, that's it. So here we are. Do you know where does this picture come from? Remember Jerry Maguire, one of my favorite movies, if you ask me. And there is a great scene when Cuba Gooding Jr. asks Tom Cruise to passionately scream on the phone, "Show me the money, show me the money." So remember this picture as it's what Microsoft will ask you to do. I'm killing a little bit, of course, but in the end, I know that majority of you stayed till this point with me to hear how much using serverless SQL in combo with Power BI will cost. And I don't blame you. That's why I intentionally left this topic for the later part of the session. First, let's examine what are you paying for when using serverless SQL pool. If you go to Microsoft's documentation, it boldly says that you will be charged for the amount of data processed. But let's go and check what counts for the amount of data processed. The first thing is amount of data read. Here you should count data itself, but also related metadata for formats that contain metadata like Parquet, for example. Then amount of moved data. So when you run the query, just recall this illustration of serverless SQL pool architecture. Your query is being split into smaller chunks and sent to multiple compute nodes for execution. While your query runs, data is being transferred between the nodes, and these intermediate results is something you should be aware of. Same as final data transfer to endpoint in an uncompressed format. In reality, you will spot the difference if you run something like select star from the file that contains 40 columns from the case when you are targeting and selecting only a few columns. Finally, amount of data written to data lake. This applies in those scenarios when you use CTAS to export query results to a Parquet file that's going to be stored in a data lake. So when you sum up these three items, you are getting the total amount of data processed. Let me show you quickly. So here, if I run this query, select top 1000 from these three views. Let's execute this query and wait a few seconds. So I will show you how to check the amount of data processed here. It should not take more than maybe 20 seconds. So we're close to end. And okay, if we go now to messages tab, let me zoom it a little bit. So you see the total size of data scan is almost 800 megabytes. Total size of data moved is 27 megabytes. So this is the amount of data that was moved between the nodes during the query execution. And of course, we didn't create external tables, so we have 0 megabytes as data amount of data written. So when you sum up all these three figures, you are getting the total of total amount is amount of data processed, which in the end will be you need to pay to Microsoft. So this one will be 823 megabytes. Okay, we will go later into details how this is going to be calculated, but yeah, just keep in mind that all of these three things counts into a total of data processed. Also, as I said, statistics, as in regular SQL databases, statistics will help the engine to come up with the optimal execution plan. Statistics in serverless SQL pool can be created manually or automatically. In both cases, there is a separate query running to return the column on which statistics is built on. And this query also has some amount of data processed. One important key takeaway here is regarding statistics with Parquet files. When you create statistics, only the relevant column is being read from the file. On the other hand, with CSV files, whole file needs to be scanned and parsed in order to create the statistics for one single column. And going back to original request for showing Microsoft the money, currently pricing starts from $5 for 1 terabyte of processed data. I think until the end of July, you have some promo period where first 10 terabytes are free of charge. So, but yeah, just keep in mind that generally 1 terabyte of processed data is starting from $5 depending on the region where your data is being stored. Also keep in mind that minimum chargeable amount per query is 10 megabytes. So even though you sometimes have a query that processed less than 10 megabytes of data, you will be charged as this minimum threshold was reached. Okay, so let's now go through the list of the items that goes on house, or if you prefer, that Microsoft will not charge you for. So what doesn't count as amount of data processed? Reading server level metadata, stuff like logins, roles, server level credentials, stuff like that. The databases you create within your server SQL endpoint, as these databases contain only metadata, not real data. So they contain stuff like users, schemas, views, external data sources, external file formats, and so on. Then metadata related queries, because they don't process data from the Azure Data Lake storage, and data definition language statements, except create statistics, which I explained previously, and the way it works in serverless SQL. Fine, so up until recently, while Synapse Analytics was still not generally available, finding out how much specific query costs was really cumbersome task. There was no way to find data about the completed queries, only those that were in progress. But let's not look back, and let's talk about current state of affair regarding cost control in serverless SQL pool. The first and most important feature is that you can set the maximum threshold for amount of data processed. The number you define is in terabytes, just for you to be aware, and you can define the maximum amount of data processed on a daily, weekly, and monthly level. So how it's done? You can do this either through user interface in Synopstudio or executing T-SQL statements again in your tool of choice. I still prefer SQL Server Management Studio to Azure Data Studio. So let me show you quickly how it's done both from Synopstudio and SQL Server Management Studio. So in Synopstudio, if we go to Manage and I hover over this small icon showing me some money, of course, I can click on it, and on the right hand side you see this cost control, and here you can simply enter the value you want to. So yeah, of course, so you can set daily limit, weekly limit, and monthly limit in terabytes, and let's apply this. Okay, that's how it's done from Synopstudio. If you prefer old school harder way, you can do this using this SPSet data process limit procedure, providing two parameters, type, which is daily, and setting the limit in terabytes. You can also check what are the current limits in sys.configuration system view. If we run this statement, select star from sys configurations, you see that our values are now 10 and 20 for daily and weekly, which I set a few minutes ago, and 100 for monthly. Let's change this and let's set 500 for monthly. I will execute this and let's check again. And you can see that now my monthly limit is 500 terabytes. Okay. What else you can do? You can check current amount of data processed. So what is the current spending? What's happening in serverless SQL pool in terms of amount of data processed? So if I run this query, I can see per type these numbers are in first column is in megabytes, this is in gigabytes, and finally in terabytes. And I also did a calculation in real dollars. So yeah, this session is free for you, but it's not free for me. So I'll need to pay in the end this significant amount to Microsoft. Yeah, so you can see that it's irrelevant, but basically you can follow your costs along the way, and that's really cool if you ask me. Okay, now as the session is called Crash Course on Synapse Analytics for Power BI Developers, here is the scenario I've used for testing how these two products work in synergy. I'm using open sourced Yellow Cab dataset, which has originally has around 1.5 billion rows. But I've extracted only small portion of data. I have two CSV files. One is for January 2019. It has 655 megabytes, and the other is for February 2019. It has 620 megabytes. I also have two Parquet files containing exactly the same data, so January and February 2019, and you can see that these Parquet files consume way less memory than CSV files. So January file contains around 7.6 million records. February file contains around 7 million records. So it's around 14.6 million rows in total. One disclaimer here, I haven't compared performance itself between CSV and Parquet, only costs. So how much would you pay for each of different scenarios? And here is the table. Of course, we don't have enough time. We will need few hours to run each separate use case. But here is the table which shows various use cases for both CSV and Parquet files and estimated costs in US dollars and short remark about the use case. In short, for CSV files, there is no difference between using regular versus aggregated tables, as in both scenarios, the whole file needs to be scanned. Also, when you compare import versus direct query mode scenario with CSV files, when you are importing the data into tabular model of Power BI, you will be charged number of times that matches the number of your data refreshes. So if you refresh the data once per day, you will pay only once for the amount of data processed. On the other hand, with direct query mode in place, number of visuals and the number of users interacting with the report will directly affect the costs of your Power BI solution. As you probably know, when you use direct query, each time you interact with the visual, query will be sent to an underlying database, and each time you will need to pay for this generated query. Simply said, stay away from direct query whenever possible. The only edge case is if you pre-aggregate data within the serverless SQL pool, but that has an impact only on extremely large data sets, because the lower amount of this transferred data, streamed data, can have an impact on the total amount of processed data, so only on extremely large files. For Parquet, it's a whole different story, as pre-aggregating data in serverless SQL pool would literally do the magic. Don't forget that Parquet keeps the data in a columnar structure, so Engine is capable to go and eliminate scanning of all the unnecessary columns. Finally, here is the list of considerations you should keep in mind when you are creating Power BI solutions that use Synapse Serverless SQL Pool as a data source. First, no matter what you perform within the Serverless SQL Pool on top of CSV files, they will be fully scanned at the lowest level of the data preparation process every time. That brings us to another conclusion. Whenever possible, use Parquet files instead of CSV. Also, whenever possible, that's general best practice in Power BI, not just related to serverless SQL, import the data into Power BI. That means you will pay only when the data snapshot is being refreshed, not for every single query within the report. If you're dealing with Parquet files, again, if you have a chance, create pre-aggregated data in form of views in the serverless SQL pool in the Synapse. So find the most frequent queries run and try to pre-aggregate data within the serverless SQL pool. Since serverless SQL pool still doesn't support result set cache, keep in mind, that's important, keep in mind that each time you run the query, even if you're returning exactly the same result set, the query will be generated and you will need to pay for it. Keep that in mind, please. If your analytical workloads require a high number of queries over a large data set, when I say large data set, I mean so large that import mode in Power BI is not an option, maybe you should consider storing data in the dedicated SQL pool, as you will pay fixed storage costs then instead of data processing costs each time you go and query the data. Here, in order to additionally benefit from using this scenario, you should materialize intermediate results using external tables before importing them into a dedicated SQL pool. That will bring additional savings. And that way your queries will read already prepared data instead of raw data. Okay, folks, that was from my side. Looking forward to hearing your questions. And in case that there is not enough time to answer all of them, or if I don't know the answer right now, I'll try to collect all the questions and get back with the answers.
Great presentation, Nikola.
Thank you.
I love it. Right. If you guys have any questions, I had disabled your access, and I will let me grant you access, guys, to be able to unmute yourself. Give me 1 second. You do have access to unmute yourself, so let's go by the order. Give me 1 second. Danish, feel free to unmute yourself and ask the question. We can't hear you, Danish. Danish? You guys do have access?
Yeah, almost all are muted. Maybe.
Yes.
I'm not sure if they have possibility to unmute.
Okay, so let me redo it again. I just redid it again. Danish, can you unmute yourself?
Actually, unmuting works, guys.
Okay.
Yeah, it works. I just tried it. Yeah.
No issue. Thank you so much,
Thank you.
Let me go to the next one. Rabia, if I say it right, would you mind to unmute yourself?
Yes. And first of all, thank you, Nikola. I really like your presentation. Actually, I attended a couple of sessions before yours, and you were one of them. And it was really, thank you.
Thank you.
And I have actually a couple of questions, but the most that I want to ask, you said that it's out of the scope, but I was wondering the use cases for why I should be using Spark tools instead of the dedicated SQL tools. I hope you can answer. If you cannot answer, I can go something else.
Yeah, honestly, I never used Spark pools within Azure Synapse, so I'm really not competent to answer the questions. Sorry.
Okay, then I'm going to ask something else. You mentioned that cross database queries are we can use it.
I can't hear you. Can you just a little bit louder?
Can you speak up, please?
Someone else is making that sound. It's not me because I'm in a quiet room.
Okay. It's better now. It's better now.
Yeah, it's not me because I think someone else did it.
Okay.
So you mentioned that cross database queries, we can use it for the serverless pools. But if we cannot create tables in the serverless pool, if we are allowed to create only database and only views, so it means that we will be only using views in it, right?
Exactly. From different databases. So you can create multiple databases, multiple views within each of the database, and then just combining views from different databases. That's it.
So, and we will not be paying anything for those if we don't run anything, right?
If you don't run anything, you don't pay anything. So only if you run the query, the amount of data that's being generated, you need to pay for it. But if you don't run anything, if it's just stored in your Azure Data Lake, you don't pay anything.
Okay, one more question. So what is the optimum Parquet file size? Let's say that I have 1 GB CSV file and I wanna convert to the Parquet file. But I think that we shouldn't be having big Parquet files. So when we convert from 1 gig CSV file to Parquet file, we need to split, I believe, but I'm not sure. I'm just asking your opinion.
Yeah, you can, for example, yeah, it's usually 1/3 of size of CSV file if you convert to Parquet. So if it's 1 gig in CSV, it's let's say somewhere between 300 and 400 megabytes in Parquet. It's not a big file.
But what is the optimum size for? Let's say that I don't know the optimum size, so I just need information from you.
Yeah, for Parquet files, there is no specific optimal size. For CSV, it is because every time Engine will scan the whole file with all the columns and all the rows. But for Parquet, there is no specific, let's say, optimal size. I really can't, tell you exact number. So because in the end, if you are retrieving only a few columns, it doesn't matter if you have a Parquet file of 500 megabytes or 100 megabytes. So you will target only specific columns from it.
Okay, thank you.
You're welcome.
Okay, Adam. Can you unmute yourself, Adam?
Yes, so thank you for this presentation, Nikola. And I have one question. So if I use a Parquet file, should I keep my data schema on the serverless views?
Yeah, sorry, I didn't hear the beginning of the question.
So if I use Parquet files, so that's in the serverless pools, I keep the data schema because I know that with CSV all will be in varchar. So for example, if I have Parquet files with date format and number format, that's in the database, I will keep the schema.
Yes, it will, but for varchar columns, I think I mentioned it, all will be treated as 8000, varchar 8000, if you don't specifically use with clause to define data types you need. So for varchar columns, it will always be 8000.
Okay. Okay, thank you.
You're welcome.
Okay, Pagati.
Hi, Nikola.
Hi.
Thank you for the session because I actually didn't. Oh, there's a noise behind. Okay, thank you. So yeah, thank you so much for the session because I actually haven't used this scenario in Power BI, but I was interested in knowing, like, have you come across any real world scenario where you have actually used Synapse with Power BI and where, it actually worked with without any issues? Like, I mean, not sure. I mean, obviously, everyone has got different experience working with Power BI, but there are certain challenges involved whenever you bring in new data source connections in Power BI. So I just wanted to know, are there any real world use case scenarios you can point to, which, for example, I can refer before starting it directly connecting, Power BI with Synapse?
Yeah, sure. So for serverless SQL pool and let's say normal Parquet files things, I did a few proof of concepts, so not real projects.
Mm-hmm.
But for I was using serverless SQL for a real client, so real project in combination with Cosmos DB. So there is a feature called Synapse Link, where basically when you're using Cosmos DB for storing data, when you activate this analytic, how it's called, I forgot. Never mind. There is two containers, transactional, and when you create analytical, basically in the background will be created a lot of Parquet files, and then I was using serverless SQL to query those Parquet files so that normal transactional workload in Cosmos DB was not affected. So in this use case, that was a real use case, real project. In combination with Cosmos DB data, serverless SQL was the good solution because I could pre-aggregate data within it for the queries generated by Power BI. And
Okay.
yeah, but one more disclaimer, Synapse became generally available in March, so I believe we will have more and more real use cases in the future.
Okay.
As yeah, in preview, no one wanted to to take a risk.
Okay, okay. And just one more question. I mean, can you like flag like top 3 things, or yeah, top 3 points or top 5 points? I would go for top 3 points, which you would suggest before. I mean, one Power BI developer should keep in mind before connecting Power BI with Synapse.
Yeah, that's a great question. So the first one is if you have data store, so large data that you can't import it in Power BI, and it's stored in kind of file, so it's a CSV or Parquet or something like that, then you simply need to use something like serverless SQL to perform kind of direct query over it.
Yeah.
That would be one scenario. Other than that, yes. So top 3 things, that's definitely one. The other one is if you're, I don't know how many clients, how many companies use Cosmos DB, but for Cosmos DB, definitely that's the way to go. Either in combination with dedicated SQL pool, depending on specific scenario, but definitely this is the way to go with Synapse.
Okay. Yeah, makes sense. Thank you so much for answering the questions.
Thank you.
Great questions, guys. Ayo Bami, am I saying it right? Would you mind to unmute yourself?
So, good evening.
Good evening.
Thank you for the session. I really gained a lot from this session.
Thank you.
It solidifies my preparation for my DP203 exams tomorrow. But I just have a few questions. Thank you. So, in a situation whereby I have very large data sets in my Parquet files or my CSV files, do you think it's best option or best approach to like load this data into Azure Analysis Services before consuming from Power BI? Or what do you think, considering the number of data and the refresh? Because for the particular report now, import mode will not be a best approach for me. So currently it's directly to the analysis services, which is on-prem. So I'm considering migrating it to the Azure Analysis Services. But I just want to hear from you. What would you suggest? What would you advise?
Yeah, this answer, it depends. If you have like one report and one user that will use this report once per day, then you don't need to import it in analysis services. But if you expect a harder workload, let's say that you want to use this data in multiple reports, multiple data sets, or that maybe in one report, but a lot of users will use this report, then it makes sense, of course. It makes sense. Maybe you can try, to see how much, just to do some tests, to see what would be the cost of running queries from serverless SQL compared to costs that you need to pay for. But if it's on-prem, if it's part of, I don't know, SQL Server Enterprise or whatever, then it's already included in the license. Yeah, probably then it makes more sense to materialize in analysis services.
Okay. Thank you.
You're welcome. Good luck with the exam.
Thanks, man.
Good luck. Yoni, would you please unmute yourself and ask question? Please unmute yourself and ask your question.
Hello, Nikola. Good afternoon for me. Hey, I have a question in regard to the automation within the Synapse scenario. Is there any tool for schedule any, for example, a delta refresh, or I need to go out of the Synapse environment to do an automation task?
Don't know. Really don't know. Sorry.
No problem.
Okay, while we're waiting on others, I'm about to share my screen. So, are there any other questions? Guys? Nikola, by the way, that was an excellent, outstanding presentation.
Thank you.
Just for some reason, the system's slowing down. Yep.
Can I just ask one more thing? Sorry, just
Yeah, sure.
came to my mind.
Sure.
So Nicola, the way you showed in this session, will you be sharing it somehow, or it won't be available? Like for example, when you connected Power BI, so is there a saved file for that where you have connected Synapse with Power BI, and will you be sharing that?
No, I don't have PBIX file. I can share presentation, is not a problem, of course.
Okay.
But I don't have this PBIX file.
Okay. No, that's fine. Okay.
Are there any other questions? By the way, thank you all for joining us. Don't forget to follow us, and also please reserve your spot for to our next presentation and also feature data-driven event. We are happy to have you today. This meetup is being this session is being recorded. I will share the recorded version with all of you later. It was amazing to have all of you. One more time, thanks all, and thank you, Nikola, for your outstanding presentation.
Thank you, Jean. Thanks
so
for
much.
having me. Thanks to all who attended, and yeah, I hope that you enjoyed.
Thank you, guys. Bye-bye. Have a good one. Thanks, Pagati.
Thank you, guys.
Thank you
Great
all.
session.
Bye-bye.
Bye.
Thank you. Bye.
Great session. Okay, bye.
Thanks all.
Thanks all. Bye.